All right, this should be the last one for 7.5 here. And we're talking about a real life problem where we know a little bit of information, but we don't have everything we need. In other words, you know how big your lot is, and let's say you're condensing it down or at least cutting off a section so you can make it another garden, in this case, a pumpkin patch. We know the total area that you own is 600 square meters. We also know where the 40-meter line and the 30-meter line for our length and our width, respectively, are. What we don't know is how big is our pumpkin patch going to be. And that's going to matter because of material to be purchased, how much tilling to do, equipment to be able to process, things like that. So we need to know the square footage to be able to get this, or the meters for all of this, or to be able to use it. I have an example of it worked out. And if you're having trouble knowing where I got the length and the width of S minus 40 and S minus 30, please watch the next video. There should be a link right below this one. Just a link. It's not a video. It doesn't look like normal. It's just a link. But make sure to follow that to see if you're not sure where I got the S minus 40 and S minus 30. But we're gonna go ahead and work as if you understood. Again, if you don't pause, go back to that video, watch it, then come back and start it again. So here we are taking the fact that we know it's 600 square meters. We also know that, and that's our area. We also know that area for any rectangular shape is always length times width. So when we found our length of S minus 40 and our width of S minus 30, we multiply them. Now, I wrote them down opposite. We're multiplying, so overall it doesn't matter. We'll end up with the same answer. And I've written down what seems to be what I see a lot of people think is the thing to do first. In order to solve, remember, in order to solve with polynomials, we want to get it set equal to 0. But we can't just jump to it. In other words, I can't just subtract this 600 and write it like I have here. This is too much too soon. What we should be doing instead, I know you had all that work to be able to copy down, and if you did, you copy down the most common mistake. So you can make note of that. And what you should say, mark it out and say, most common mistake of everything I just erased. And then below it say, instead. Instead, what we're going to do is first we're going to FOIL. So our S times S is S squared. Our S times negative 40 is negative 40S. Our negative 30 times S is negative 30S. And our 40 times 30 is 2 zeros, 12, and a negative times a negative is a positive. Okay? So we have FOILed out our polynomials. Now I can take off that 600. So over here, 600 minus 600 goes to 0. But I have moved that negative 600 over to the other side, and that's going to leave me with 1200 minus 600 is 600. Now I want to combine that negative 40 and the negative 30, and that's going to be negative 70s. And remember, the 1200 was bigger than the negative 600, so I'm still actually adding here. And before all this, I had my S squared because nothing changed there. So what I'm trying to ask myself is, what multiplies up to 600 but adds up to negative 70? So this is a case where B is negative, but C was positive. And I believe that was from example 2. So if you have a little bit of trouble remembering that, go back to example 2. So here I know that 40 and 30 add up to 70 and will multiply up to 1200. So what can I do to kind of take away and get, what can I do, because 40 and 30 is what I would have seen here as my answers, but that's not right. And that was kind of the illustration of why we don't just subtract 600 and go from there, because we would have had the same 30 and 40. So I know these can be and are factors, but are not the right ones. What I do know is 20 and 30 multiply up to 600. but they add up to either 50 or, if they're both negative, negative 50. So I cannot use these. So we do 10 and 60. If you notice, real quick, I want to add this in there. Really, if we just get rid of the zeros, that's what we're really looking at. 4 times 3 is 12. And remember, 12 was too much. That's why we took it out and didn't do it in the first place. But 2 times 3 is 6. And 1 times 6 is, again, 6. So really what we're looking for is just the factors of 6, and we add a 0 behind them because we're going 600. We need 2 zeros, 1 behind each factor. Now, if that didn't make sense to you, get with me. I'll talk to you about the properties of tens. All right, so we get 1 and 6, or 10 and 60. Well, that's either 70 or negative 70. Ha-ha! We get it. We got it. We need negative 70. And 70 was the key number here. So I need to realize, how do I get negative 70? Well, that means I've got to have a negative 10 and a negative 60. So I'm going to come over here and I'm going to say S minus 10 times S minus 70. And that is my polynomial that I can then set equal to 0 to find that one side is a length 10, or the sides are either a length 10 or a length, oh, I put 70 in there. I should have written this 6, not that sound, so 60. All right, so the area is 60 by 60, and I know that because S can't be 10, because that would mean the whole side, the orange side here would be 10, and the other side would be 30. That doesn't make sense because only part of the side was 30, and the full side being 10, that can't be. So the answer that makes sense in this case is S minus 60. It's not that S minus 10 doesn't exist, but it's not the one that makes sense. The one that makes sense is when S is equal to 60, and I can get that when I get S minus 60 equals 0, add 60 to both sides. S equals 60, or the length of a side is 60 meters, because the length of the side being 10 meters doesn't make sense. So our final answer is not S minus 10 times S minus 60, it's S equals 60 meters.